So in today's session, we'll be covering what is blockchain. Of course, we have to define what is blockchain because that's the introduction of the same. And then we do the key concept of the blockchain, the uniqueness of the blockchain technology. And then we do some blockchain development tools, like the tools you need to like develop something in blockchain. And then we talk about smart contract and solidity. Well, those are ideas of more of like some smart, what do you call them? The Solidity is a programming language. Is the language you use to code those developments. And then you have blockchain development languages. We have like 3. And then you have use cases of blockchain. Moving on. So what is blockchain? Okay, the best way you can think of blockchain, you can think it like a digital ledger. It's a distributed in a decentralized digital ledger. Yeah, from your previous knowledge, maybe in business or your bookkeeping records, maybe you have a shop or something somewhere, you know what is a ledger. Ledger is basically a place you can keep records. You just keep them neat, you know the liabilities, the credits, and the asset and all that. You can just have those ledger is basically a book where you keep your records. So blockchain is a ledger, but digital ledger used to store transactions. As I explained last week, that's actually the relationship between the blockchain and cryptocurrency. Cryptocurrency, it involves transactions of buying and selling and receiving and sending. All those transactions of cryptocurrency are being recorded in the blockchain ledger, because as you have said, blockchain is more of like it's distributed in a digital ledger. So just like the bookkeeping, the normal bookkeeping, is the same thing that happens here. So the cryptocurrency records, transaction rather, are being recorded on the blockchain. So blockchain is a distributed ledger, but it's more unique than the actual ledger you have, like the actual book you maybe keep your records, because this one is more secure and it's immutable, meaning that if you add a record, you cannot delete it. Immutable, that brings along transparency and a lot of security, because at some point you might edit ledgers. People normally do that, but the blockchain actually cannot edit. So there's that transparency, and when someone sees it casually, he can trust it because he knows you cannot edit it, and it's being verified by the rest of the members. So that sense of trust between the people using the blockchain. And then the old block thing is more like the records are being recorded in forms of block, and then that block is being attached to the other block. Now that's forming some sort of chain that hence the name blockchain. So basically the transaction are being recorded on a block, maybe let's say 400 transactions or maybe 200 transactions are being recorded in a specific block. And then that block is being attached to the previous block that was there before it. So, and the one that comes after is being attached to this one. So it's more like they're linked, something you can think of blockchain, some sort of a double linked list in the computer science terms, but I'm trying to avoid technical terms today. But it's that way. So blocks, and then you link to the previous one, and that's forming a chain, and the name blockchain. And then you have something called the node. The node is not much of a technical term. It's basically the parties in the network. You see the people who are participating on the network. We have people who are there, like maybe you're there to buy your cryptocurrency. As a user, you're not really a node. I mean, the people who enhance the functionality of the network, now those are the nodes. They're basically computers. They provide the processing power, they give their computing power and actually the power, because they include the computing power to the network, and they enable the smooth functioning of the blockchain. So those are the nodes, but it's basically the computers. And in some areas, you can hear them being referred as miners, are the same people actually. The nodes are still the miners, and yeah. Okay, we have now the key components of blockchain. Okay, blockchain, of course, we have discussed about the nodes. These are the computers participating in the blockchain network. They help with the verifying the transaction and keeping the network secure, and provide actually the computation power to process those transactions. And then you have transaction now. Transaction is the record stored in the blockchain. Transaction is like normal transaction or a normal entry you normally make on a day-to-day basis. So transaction, you can think it looks like a data record. Now these transactions are being stored on the blocks. Okay, and blocks are some sort of containers. They can hold a big number of transactions, maybe let's say 300, but it depends with the transaction weight or the length. So there's some transactions are kind of big. And the same thing you can see, you can withdraw a big amount and a less amount, and then the storage and all that thing is kind of big. So some transactions are big. But now when you compile those transactions together, you add them in some sort of container, we call it the block. Now that block is being attached to the previous block, forming a chain, now hence the name blockchain. So the third one is called the consensus mechanism. Okay, if you recall, I've just said that blockchain is decentralized by nature. That would mean that there's no central party who makes the policies or like decides who wins or who controls the functioning of the network. So what really happens, these people, they agree. It's more like a democracy, you vote. The vote with the majority wins. It's like the normal democracy how it works. So there's no CEO, there's no boss, there's no nothing. You just engage in the consensus, you do your mechanism, whoever has validated the node and everyone else approves that you're the right person who has the right transactions, then we go with that. It's more of democracy. It's called the consensus mechanism. It's one of the unique features that makes blockchain decentralized. Now with this one, you don't really need like a central authority to create policies or to govern the functioning. It's just done with democracy. It's the power of the people. Now, those people who participate on the consensus are those the nodes I was saying, they are like the miners or the people who are the computers participating in the blockchain. And then you have another important component we call the cryptography. You don't really need to know the details of the cryptography, but cryptography is basically it's used to ensure security and the data integrity in the blockchain. Okay. Okay, on the blockchain development tools, okay, we have Ethereum. Okay, Ethereum is okay, now, if you recall last time where I said Ethereum as a currency, okay, there's Ethereum as a currency, something called the Ethers, and then we have Ethereum as a blockchain. Okay, Bitcoin is a blockchain on its own, and then Ethereum is a blockchain on its own. And there's some features that Ethereum are not in Bitcoin that make it more favorable for the development because it enables it executes something called the smart contract. We'll explain that later, but now blockchain is way much better because it allows developers to like develop the business logic of the network. Now, unlike Bitcoin network, it kind of allows us to, but it's way too complex and hard to implement, and it's kind of not scalable. So Ethereum as an upper hand on that. So popular blockchain platform for development is Ethereum. It's the largest actually by far right now. And then there's something called the Ganache. It's a local. It's a local. Okay, it's used for testing and development. It's more like a development environment on the blockchain, on the Ethereum blockchain. Then you have Remix. Remix is an IDE. IDE is so it's more of like we call it what? The integrated development environment for Ethereum. Okay, Remix, it's something, okay, an IDE is something where it's a development environment. You can think of something like the Dev C++ for the C++ developers, or, you know, an environment. And then, yeah, so Remix, it's where you just write those smart contracts, you write it in Solidity, and then you can use Ganache to test and do the development. And then we have the Trafo. Trafo actually is used for it's more like a framework based for applications. It's more like just a framework to both deploy, test, and develop those blockchain development. And then you have MetaMask. I didn't explain this sometimes back. MetaMask is a wallet. It's a cold wallet. You see, in blockchain, you need to pay something called the gas fees, and you need to have like cryptocurrencies to pay that. So Ethereum, it's not Ethereum, MetaMask, you can use that to hold your cryptocurrency and make those payments for the gas fee or to make any transactions. So maybe when you're testing, you can get something called the testnet coins, like not the actual coins, but some testnet coins. Then you can use them to see the functionality of your application, or maybe the the software developing, how it's interacting with the blockchain, and how it's sending and receiving transactions. So MetaMask is quite important because it is the one we use for testing, like on the transaction aspect. And then, okay, you can think it, maybe you are, okay, you can think of the, on the real life, if you're developing an application that you need to integrate with the bank, of course, you need maybe something like a bank from somewhere to see how the transaction is working, to send some money and receive, and that's all. So you can think MetaMask of a similar thing because it's offering the same objective to kind of receive and send those transactions on the Ethereum network or blockchain, the same name. So moving on, we have now the smart contract. Okay, smart contract, the best thing to think of them is more of like it's more of an online handshake. You see, smart contract, they're the one that are eliminating actually the middleman, or maybe on a contract. I'll just give you an example, at least to understand smart contract better. Okay, suppose you want to send someone money through a bank. Of course, you need the bank as a middleman. You send them money, the bank will take some charges and then transfer the money to the receiver's account. Now, what bank has done has been acted as a trusted third party that you trust him and the receiver trusts him. So you trust him to make the transaction for you. Now, with the smart contract, we'll eliminate the bank and then we replace that with a code, a written code that explains how we want it added. We have said you do this work and then you pay this amount. If I do the work, then the smart contract makes sure you have paid me. So the smart contract is more like it's smart, like the one stated, but it's not really smart because smart softwares maybe are AI integrated, but it's a self-executing code. It just executes some predefined code. You can just sit down with your other counterparty, and then you can write down your rules, or maybe the policies, or maybe the, what do you call them, the instructions of how you want things handled. And then once this is done, the smart code does the other one. So it's more like it will execute itself once the conditions are met that were predefined at first. So two parties can come in, and then you have the conditions, and it is that. And once this condition is being triggered, it triggers an event on the smart contract, or maybe on the blockchain. So that's the smart contract. And then your Solidity. Solidity is basically now the programming language that uses to write the smart contract. Actually, you can write with other languages as well, but now Solidity it's immutable because it's being written on the blockchain. You can actually write a smart contract in any other language, maybe Python or Android or Java. You can just write it with a different language. The only problem with the other languages is that they're not immutable. Maybe someone can just come and edit the code and then it is executing something else. But now with Solidity, because it's being deployed and written on the blockchain, it's immutable by nature, so you cannot really edit it once it's being deployed. So we have Solidity in the programming language, and then we have Solidity features. Like any other programming language, of course, it got something called the variables and the functions, modifiers, and the event. Event is those it's more like the events you're handling on the predefined rules and all that. So like any language, actually, any other language has the same features. So moving on, we have the blockchain. Okay, the blockchain development languages. Now this is a little bit, it's quite interesting because you see, there are three. We have Solidity. I'm saying that is the primary language for development, smart contracts in Ethereum. But soon as we have something called the Vibe. The Vibe is more like Python-like. If you're a Python developer, you don't really need to learn Solidity. You can learn some little bit of how you can actually write smart contracts using Python. It's more like Python. Like if you're a Python developer, then it's easier to adapt to the Vibe. And then you have something called the chain code. Now this is for the Go developers. If you're a Go developer, it's easier to learn the chain code rather. And then it's for Hyperledger Fabric smart contract, the same thing to the smart contract, and then you can deploy your logic on the blockchain and see your application work. Okay, before at some point, someone might ask if you just need to know only blockchain development. You see, blockchain is majorly works with the backend part of the application. So if you are maybe you're a front-end developer, you still need the front-end aspect to design your interface and how users will be interacting with the system. So there's that other interaction, not interaction. There's that other aspect of like integrating blockchain with other languages or maybe other functionalities, not like it's not a standalone thing. You need to be, we can text, okay, maybe we can create a React application and then you use blockchain on the backend. That is, you eliminate the database and all that, and then you can store your data on the blockchain. So that's how blockchain really works actually. But still, they're both skills. If you are developing a specific language, it's very easy to adapt to blockchain. Actually, you don't really like need to start from afresh. But when you understand the basic concept or maybe the main component of the blockchain, that it really works, it really is actually to implement your language. Not your language, your active, okay, your field of specialization on the same and actually provide solutions on your field with blockchain. Because one of the major features that blockchain is really carrying is more of like the transparency and the immutability aspect. So it kind of brings more trust on the system than the other paradigm, like the client server model. We normally use that one, right? So we have the use cases of blockchain. We have, of course, my favorite one, we call it the supply chain. The supply chain, I really feel it's one of the things that we really need, like some serious solutions here. Because being in Kenya, we have had a lot of cases of maybe having some intoxicated sugar just comes over and just disappears, or maybe it's serving mercury or something. So there's those issue of the supply, or maybe you have an issue of counterfeit goods. Being a Kenyan national, that is like more of like a common thing. We hear that every day. Now with the blockchain, we can improve that and make the supply management more transparent. That if I just log into the software or not a software, if maybe I'm buying a sugar or maybe I'm buying a cooking oil, we have on the package, we have something like a QR code, and I can scan it with my phone, and then I can see the supply chain of that product until when I'm having it, maybe from the manufacturer until here. And now with that, I can trust it because we know blockchain is immutable, so the records are not altered; they are the actual records. So in the supply chain, there's a lot of possibilities actually to improve on that. And then you have something called the financial services, that is for the payment remittance. You see, when you're doing like the online payment, you make a lot of payments on the, okay, you pay a lot of fees, which are not really necessary because banks actually charge you even if you are sending to another same bank user. You're like, okay, you're the same user of the same bank, but still they're charging you high, and just a normal transaction within their customers. So you notice like the banks and all these other current financial systems you're having, services, they're very expensive on the fees. But in the crypto, it's quite cheap actually. If you make any transaction, maybe you're sending someone Bitcoin, you will see you're paying some 0. something, like very minute details of a very, very small number. So it's kind of cheap. And then another good thing, it's fast actually, very fast, because it runs on 4 hours and there's no shutdown, there's no going down. Provided the blockchain is up and running, then you can have your money anytime, anywhere. There's no like what do you call it? The border barriers. You notice that sometimes if you're in Kenya and you're sending someone money in the US, or maybe vice versa. Okay, there's just maybe some verification period, like a day, or maybe like 4 hours, or maybe like 6 hours, just verify the transaction and then transfer to a different bank. Okay, that takes a lot. Now, with blockchain, provided the receiver and the sender are on the same network, then it's just simple. Within a blink of an eye, they're just transferred. The node that is active, it makes the processing, and then the money goes. And then you have other aspects, something like the healthcare. Now, with the healthcare, we have a lot of sensitive records in the health. Maybe you don't want people to see your medical records. They can use them against you to blackmail you, or maybe your insurance company don't want to let them see your medical records and all that things. At some point, that urge to keep our records private. So with blockchain technology, it can help you be in more control of your data, because now with a third party controlling your data, you're not really in control because someone else is really controlling your data, and you don't know who is handling it, who has access to it, and all that. Now with the blockchain, it just gives you a better way of handling your data, and then you'll be in charge of your data. So that's a good thing for the healthcare. And then you have identity management. We have a lot of issues actually with the identity management. With the blockchain security and showing that who is who, it can actually help curb that issue of the identity management. And then you have something called the voting system. we have always had issues with voting or maybe rigging of elections and all that. Now with blockchain, you see now the data is alterable. So you cannot like add your own vote or maybe they do some vote. No, we just have the actual amount. There's that aspect of transparency in blockchain. You cannot really make some changes without others noticing. And then lastly, we have the decentralized applications. And this is the same aspect I'm talking about, like any other application, and then we incorporate blockchain in it. So getting started with the blockchain, what we really need to do, first we just need to learn the basics like we have done today, and its underlying technology. And then we can start the programming language used in blockchain for Ether solidity. And then you can familiarize yourself with blockchain platform and tools, like the one I've explained like Notrafo, Remix, and the Ganache. And then you have experienced the smart contract and develop on the test networks. Of course, you do your testing with the test networks, and then when you feel comfortable, and then you can deploy it to the production. And then you have joined online communities and forum for guidance and support, like what we're doing here. You just need to be a member of a certain community or a forum, and then just get encouraged. Those you can access someone, ask them questions, and have a better experience on the same.